Thank you everyone for joining today's session. We obviously wanted to bring together members of the Chaos Toolkit community and the wider reliability community to really hear from those that are leveraging the Chaos Toolkit and looking at how they are becoming more resilient and reliable. Just some housekeeping: if you have any questions, please do ping them in via the chat, and we can go through those at the end of the talk. We are going to be recording this session and it will be shared out after, along with some useful resources after the session. So we're delighted to welcome for today's guest talk Manuel Castellin, a seasoned expert in chaos engineering and Terraform. Manuel's going to explore how pairing Chaos Toolkit with an infrastructure automation tool like Terraform can help orchestrate more advanced chaos experiments, and is going to be taking us through a couple of real-world examples. So very excited for that, and there will be plenty of time for questions. And then to wrap up, we have Sylvain, Reliably CEO and leader of the Chaos Toolkit, who will be giving an overview of how you can simplify building valuable experiments and discovering where you're at risk with the power of Reliably, which is built upon Chaos Toolkit. So let's begin with Manuel. Over to you. Thanks.
Thank you, Adele, for the kind words. So hello, everyone. My name is Manuel Castellin, and I'm going to be the presenter for today's session. In this session, I'm going to talk you through what was my experience with Chaos Toolkit and implementing chaos engineering on existing infrastructures. Of course, this comes with different challenges because, of course, infrastructure that aren't made with chaos engineering in mind can sometimes be tricky to work with. But I'm going to talk about that a bit later. First of all, I just wanted to give you a quick introduction about myself. So I'm a software engineer by trade. I've always been passionate about Linux, system administration, automation, and as soon as I learned about cloud technologies, I immediately jumped on that train. I thought it was fascinating. And I slowly started to leave my career as a software engineer and transition more to a site reliability engineering role. And at that point, I discovered chaos engineering, and I was absolutely hooked. It was a super cool subject. A lot of big companies were doing it, and the concept itself, I believe it's amazing, like trying to really test your system that way. Today, after a few years working with Chaos Toolkit, I now maintain a few projects, open source projects on GitHub. One of those is the Chaos Toolkit Starter Pack for AWS, which is essentially a collection of chaos engineering experiments that can help people kickstart their the chaos engineering implementation if they work with AWS native resources, and some more. In my spare time, I like to do landscape photography and blog about technology. So whenever I have, like the little time I have, so it's not a lot these days. But anyway, let's crack on. So I'm going to talk to you about how to inject faults on existing infrastructure. So why should this be a problem and deserving its own platform? So first of all, it can be challenging if an infrastructure is not designed for fault injection. If you think about software development, for example, if you ever worked as a software engineer, when you try to create unit tests on existing programs, it can be tricky, especially because the code's not been designed to facilitate that. So the same goes for the infrastructure. So if you didn't think about injecting faults at the start when you designed the infrastructure, sometimes it's just not possible. Like, for example, if you have a direct connection between two services, it's going to get a lot trickier to control the network conditions if you don't have any sort of service mesh or proxy in between them. So that's what we're trying to address during this presentation. Of course, it's because the infrastructure wasn't designed for chaos experimentation, it doesn't mean we can't do it. It would probably just take a little bit of extra setup, and we'll have to create some resources before we can effectively execute experiments. Something to be aware, because it beat me many times, we need to be aware of information recovery blind spots. So if it's first time you experiment on an infrastructure, if you try to go too big too fast and, let's say, completely erase a database or a bucket, just make sure you are 100% certain your recovery practices are on point, because it could be that you cannot get your data back. And of course, when that happens, it kind of triggers like a domino effect, and people start to fear running experiment on production. We lose confidence on whether we can run them directly on a live environment, because we are afraid of losing data or resources that we can't recreate. And of course, shareholders will be concerned about lost revenue if we have downtime because of a chaos experiment. Now, question is, can I start chaos engineering immediately with my infrastructure in my organization? And the answer is, of course, yes. Just needs a bit of extra consideration. So here's my advice. Typically, of course, we discussed that if the infrastructure isn't ready, it can be difficult to inject faults, but it's not an excuse to wait for a top-down refactoring of the infrastructure. So we don't have to wait for the infrastructure team or the company to allocate budget and recreate the infrastructure the way we like it. We need to be a bit creative. It's just the way it is. We need to be a bit creative and try and deliver value anyway by working around this problem and maybe create some automations that can help us inject faults anyway. Of course, if cost is a concern, it always is at the start of the project because it didn't deliver any value yet. So using open source software has also been a big component of my work as well, because when I started, just me, myself, and I looking at chaos engineering and trying to implement some solutions. And of course, I didn't have any budget to allocate for these tests. So I started immediately with Chaos Toolkit and used as many open source tools as I could, and that greatly improved my experience. Let's say I didn't have to go and buy a commercial product to start with chaos engineering. That's beautiful. Of course, first rule is just be a good citizen on the infrastructure, and I probably need to explain this. So do use test or pre-production environments, and don't break production. This is especially at the beginning. I'm saying this because when you read Principles of Chaos, of course, you want to be experimenting on the infrastructure that ultimately you want to test. So that's going to be your live or production environment. But even though big companies do it, there's no shame in starting small with a test environment. Maybe try to get a sense of what your experiment do. And this is what I always do anyway. I start with a test environment, test my experiments, see if they're implemented correctly, see if all errors are handled, and then when I'm confident they're going to work, they're not going to cause any disruption, I'm going to slowly move them to production. This is quite important because if you push too hard and cause trouble on your production environment, shareholders will start resisting this type of change, and they probably even ask you to stop running experiments altogether. And that's, of course, not what we want. So there's no shame, even though you should, as a principle, experiment on production, there's no shame in starting small and starting on a test environment. And of course, as I already said, consider starting ridiculously small, like ridiculously simple experiments. Even like deleting a single container when you have already 10 replicas can help you learn something more about your system, because you can simultaneously test if you can recover from that failure, if the remaining 9 containers can withstand the current load, and even if you can effectively restart a new instance, for example, when one fails. So don't be afraid to start small. Even the smallest experiment can deliver value. You just have to look and try to ask the right questions. And of course, one other thing that comes with using open source software, don't be afraid to customize your tools. When I started chaos engineering, I expected to find a tool that I could simply just plug and play and have my experiments running on the infrastructure. That's not how it works, especially if you take advantage of open source software. Maybe paid solution and commercial solution may be different, but that's not the case for open source most of the time. So don't be afraid to customize, learn how your tool is working, and try to customize it to fit your own infrastructure. That will greatly help you down the line. And of course, always be looking for inspiration. That's what I do on a daily basis. Like, look at other projects, look at different tools, how they do things, what's their process, and try to replicate it into your own infrastructure. That's how I make progress, and that's how I recommend you do the same. Especially if, like me, you started out having no idea what to experiment on. I found that looking at other implementations has greatly helped me to find ideas. Now, let's see a practical example. So why applying chaos engineering to existing infrastructure can be a problem. In this example, we have a simple enough application. It's just 2 microservices and a database. So the microservice A is configured to communicate with microservice B with and via its IP address or DNS name directly. And the same goes for the MySQL database. So service B is configured to connect directly to the MySQL cluster. If you run in AWS, it could be in RDS or any other data service. But at this point, like, how do we inject network condition? How do we change the variables of this environment without with the current structure? So one way to go about it, of course, would be to just deploy a TCP proxy and route the traffic from service A to service B through the proxy. That's simple enough. Of course, it does take configuration. It doesn't come easy, especially at the beginning. But we need to do some sort of reconfiguration unless we already have a service mesh on our infrastructure, which is already one step further. Maybe that's something we will have later on, but at the beginning, this is where a lot of people start. So what is Chaos Toolkit Terraform? Because I found myself having to repeatedly modifying the infrastructure to allow for chaos engineering fault injection, I designed a tool. This is open source, of course. You're free to install it in your own Chaos Toolkit configuration. You just need to use the command down below. This is a Chaos Toolkit module that integrates the infrastructure as code capabilities into Chaos Toolkit experiments. It allows to automatically deploy supporting resources for experiments, like we saw earlier, or we can deploy a TCP proxy on the fly just for the purpose of the experiment, and then use it to inject network latency, for example. Chaos Toolkit Terraform also allows the exchange of variables between Terraform modules and chaos experiments in Chaos Toolkit. That is important because it promotes reuse of components. For example, that TCP proxy can be used for can be injected between microservice A and B, or maybe can be used for a database, or maybe I need multiple ones. So it's important that every module is customizable for our needs. Of course, using an infrastructure as code tool is a cost saving, because we could decide to, okay, I need a TCP proxy. I'll just deploy one, leave it there, and use it when I need to reconfigure services for my experiments. But of course, it's just a cost. I'm not running chaos experiments all the time. maybe it's just once or twice a day. So having these resources deployed costs us money, so we want to save as much as possible. That's a benefit. And security as well, because whenever we run a chaos experiment, we typically need higher privileges for those components, because we need to be able to destroy resources, reconfigure them, stop services. So if a hacker ever gets his hand on one of these supporting resources, it can do some real damage. So we don't want to have them around after the experiment is finished. Maybe we use a few minutes and then destroy them. That's important. So how do we use Chaos Toolkit Terraform? The module exposes control. If you're already familiar with Chaos Toolkit, I know this is fairly technical, but I hope everybody can understand. A control is basically an extension of the experiment that adds additional steps to the execution. So in this case, Chaos Toolkit Terraform will be able to deploy resources before the experiment starts and destroy them after the experiment is finished, regardless of the result. So it's fairly simple. It's just boilerplate until here. And then we have a few arguments. As I mentioned, we can configure its behavior and have it also share variables between the experiment and the Terraform module. And you do it via the variables and output configuration. But yeah, documentation will cover that as well. And now it's time for some demos. Now I have two examples today. One will be to try and see in practice how we can intercept the network connection between two cloud components and use Shopify's toxic proxy to control and add some network latency. And the second will be about cybersecurity and a new branch of chaos engineering called the security chaos engineering that I just started looking at, about one thing at a time. This is the first example. Of course, there's looking at the service and the database, in this case, running on Amazon RDS. There's a direct link configured between service B and its database, and it's via IP address or the DNS name for the RDS cluster. And it doesn't allow any control on the network conditions, because we don't have any service mesh or any custom proxies or load balancers that help us do that. So what we need to do is do the same configuration as we saw earlier, deploy a toxic proxy instance on EC2, and reconfigure service B to talk to RDS through the proxy. So of course, we're going to use Chaos Toolkit Terraform to deploy resources. We configure toxics with Chaos Toolkit to simulate this increased DB latency condition. Of course, we're going to reconfigure service B, that's a given, and use Chaos Toolkit to reconfigure the DB and route the traffic through the proxy. So let me move on to terminal. And what I have here, if everybody can see my screen correctly, I have a Terraform module that has a few sections. So we have variables that will allow us to configure how this module is deployed. And we have resources. In this case, we have a security group for the toxic proxy instance. And then we have the another module, a submodule, that will be responsible for creating and installing toxic proxy into the infrastructure. This is going to happen on the fly right before the experiment execution. And at the end, we have an output section where the module exposes two important information: the admin URL that Chaos Toolkit will use to control the proxies, and the toxic proxy private IP address, which will be the IP address where our service B, that our service B will use to communicate with its database. So we are sitting this instance in between the two services. Now, if I can change. So of course, I've stored this Terraform module into this stacks proxy directory. Now, let me move on to the experiment file. So I'm using this experiment ECS service load data source for our demo today. And this experiment, what it does, it has the controls section for Chaos Terraform, where we, of course, change directory to this 2 levels up stacks proxy. By default, Chaos Toolkit Terraform will look at the module inside the current directory, but you can specify another one, just like Terraform. Then we're going to use some extra variables to configure the module. We can use variables directly by providing a value, or we can hook the variable name with an existing variable of the Chaos Toolkit experiment, so we don't have to fix those up in the YAML or JSON file. So in this case, we are referencing for environment the environment variable, this Boolean to this other variable, etc. And outputs as well. We're going to read the outputs from the module and map it to a toxic proxy URL configuration variable. Chaos Toolkit Terraform will also export variables by default with a prefix, but we'll see that in a minute. So here we have a bunch of configuration. It doesn't do any good to look at this. The hypothesis for this experiment, we want to be able to inject an additional 200 milliseconds of latency for every DB request, and still our service should not crash. This, of course, looks at the observability stack for the infrastructure. So in this case, we use CloudWatch, and we have a custom probe to verify that the certain alarms are not in a failed state. So expected states can be okay, or insufficient data is also fine, but we don't want to get to the point where the service is failing. And of course, we have a second probe to verify the service is responsive all the time. We're going to run this hypothesis continuously for the experiment. And the method, so this is quite long, so I'm going to skip through a few things, but in essence, we have a step to configure the proxy. We have another step to change the configuration of the service, and so it can talk to the toxic proxy private IP, as you can see here. So we redeploy a new version of the service before we start the experiment and change the data source URL to something we can control. Then, of course, this is a test environment, so we ramp up some generated load, and then we can control the network condition by asking toxic proxy to change to introduce a toxics, a so-called toxics into the proxy. And this is going to target latency, and it will add a minimum latency with a jitter value. And these two values are, I already know about them. They are 200 milliseconds with a jitter of 50 milliseconds. And then, of course, we continue generating some load just to apply some stress on the system. And then we roll back by restoring the original state of the service and delete the toxics. Now, let's go and run this experiment. Of course, just this is going to take about half an hour to run. So we don't have that kind of time. So I'm just going to disable all of that. I've already pre-run the experiment so we can look at the results. What we want to see here is actually the functioning of Chaos Toolkit Terraform. So we add the pauses after 300 seconds. We can always stop it later. And then we can do, sorry, I have a utility script, but this is just Chaos Toolkit. Start Chaos, library, slow data source, and I have my experiment configuration. Okay, so this will run this long command. As you can see, this is Terraform doing its job. It started deploying resources. and the experiment hasn't started yet. So if we go to the top, we notice the Chaos Toolkit experiment started here, actually here. And then at some point, we are now, okay. So we are now deploying all the resources. Sorry, it's a bit fiddly sometimes. We started to initialize the module and start creating Chaos resources for the experiment. And now it's finished. Okay, it created 8 resources, and we have these 2 output values. As you can see, Terraform is reading these values and injecting them into the experiment. Okay, so we got to a point. Now the experiment is just waiting, so we can analyze what happened. If we go to EC2, we have this live ToxiProxy EC2 instance. This has been deployed automatically by Chaos Toolkit Terraform, and it's now configured with this private IP address, 10.04.158, and that's probably going to be, this is the public, oh yeah, private IP, there you go. This is going to be the new IP address for the service to reach its database. Now, if we move on, of course, as I mentioned, I've already run the experiment. So let me just find it. 3 hours. I think it is this one. Okay, so we can look at the metrics. Okay, maybe here. Okay, so this is the experiment. This is how what it looks like. We have this API service that will be the one talking to the RDS database. So we can see the latency has been very low, 0.01 for a warm-up time. And then at some point, we introduce some additional latency. You remember 200 milliseconds. Of course, it's not exactly 200, first because of the jitter, and second because we can have multiple DB calls in a single API endpoint. So this is exactly the experiment happening. So we have the ramp up and then the latency increase, and then when the experiment finished, the latency goes back down again after the end. I just wanted to show you something. Like this morning, I've been doing some experimenting with it, and with different number of simulated users and different type of latencies. And actually, you see that if we look at the latency here, most of the time you see the ramp up and then a big spike. This is actually the service crashing. So I effectively verified that for certain level or latencies, our service could not withstand the current traffic. So with this first fail attempt, second, third fail attempt, and this was actually the one that worked, where we could sustain the additional latency for an extended period of time. Now, the experiment, we can stop the experiment now. And after, it probably has some verification to run. And after the fact, it should be able to destroy the stack correctly. Let's see if it wake itself up, or we need to do it manually.
You may have to type Control-C again, because you're in Python land and you're in logged call. So you may have to type Control-C again just to try. Because
of the pauses.
Yeah, because it's in time sleep. So basically, it's
yeah, it's a good thing. Good thing we have Sylvain. Okay, let's remove the pause because we didn't see the. So let's run the experiment again. This shouldn't take long at all, because the stack is already there. So we just want to see the destruction part. So of course, this time we don't have any change because the infrastructure already exists. Now we have only one method. Yeah, apologies everyone, bear with me 1 second. Okay. And now we have the destruction part. You need Terraform. You see Terraform is destroying all the resources after the experiment is finished. And if we can take a look at the EC2 instances, Yeah, this one's terminated as from a previous test, and this one is shutting down. So yeah, as you see, Terraform is a great tool to combine with Chaos Toolkit because it can help you automate all that and eliminate human error. So you don't have to manually create resources or modify the infrastructure before you run complex experiments. So while we wait the infrastructure fully shut down, yeah, there you go, we can move on to the second demo. And this is going to be about cybersecurity. So security chaos engineering is a very interesting branch of chaos engineering. And I found it fascinating because of it's the same as the resiliency chaos engineering, but with a few nuances that actually differ from the typical chaos engineering experiment. And this is mainly about verification. So with resiliency, we want to verify that our system maintains a steady state. So we don't want to see any error. The site should be online most of the time. With security chaos engineering, we actually want to verify notification. That's mainly what should happen. So we have monitors, we have tools to promptly identify security attacks, and we want them to work correctly. So that's going to be the goal for the second experiment. So the number, just to give you some stats, the number of ransomware attacks from 2022 to 2023 is already up more than 95%. And that's concerning. And this is especially true because it not only concerns our laptops, but they are real threats for cloud accounts as well. So we need to be able to protect the resources when we host any type of website or infrastructure in the cloud. Of course, it's possible sometimes for certain types of attack to identify early signs, and we're gonna see how in a minute. Of course, we have security teams in most companies, and if they are notified early, they can promptly address the issue, lock resources, and facilitate data recovery. So just to explain a little bit this experiment, we have a potential attacker. We have some data like access logs for a load balancer that we may be required to keep by law for, I don't know, a year. So we don't want to be losing these data, otherwise we could incur in lawsuits or all sorts of troubles for the company. So if an attacker ever tries to run a ransomware attack, it will show early signs. Like he would probably try to download your data first and then delete them or encrypt them and then upload a ransom note. So because of that, we can configure, in this case, an S3 bucket to publish metrics into CloudWatch, and we can have monitors and alert to send notification through SNS, which is the simple notification service for Amazon, to notify security teams via chats or emails about the security threat that's currently being run. Why do we need chaos engineering about all this? So we want to make sure that when an attack happens, our tools can effectively notify our team about the attack. So we can design an experiment like this. We can, as I said, it's all about verifying the alert is happening. So we don't want to fix the issue with the chaos experiment, or we don't want to fix the issue automatically. It's not like resiliency where, let's say we have Lambda functions or any kind of automation that can fix the infrastructure when something happens. But rather we test for the notification. Of course, what we don't want is lose any important data. So we don't want to be running on production a delete operation directly into the access logs bucket, for example. What we do instead is use Chaos Toolkit Terraform to create a dummy. So it's completely safe at that point to attack the dummy because we don't have any important message there, also any important data there. We can just use it to attack and verify the notification is triggered correctly. The way we do that is still use Chaos Toolkit Terraform to temporarily create an SQS queue that will receive the threat notification and feed back into Chaos Toolkit. We'll see in a minute how that's done. As I said, it's totally fine if we use a dummy, so completely safe. Your stakeholders won't be mad if you try to attack on a live environment a dummy bucket. It's not going to do any harm. So you may get some more go ahead if you refuse to attack real buckets. And of course, we use Chaos Toolkit Terraform. Now let's move on to the demonstration. Let me close this for a second. And the second experiment, we have the Terraform module. The Terraform module has two variables. Of course, the topic ARN, which is the essentially the ARN of the topic in SNS that will receive the notification from CloudWatch. And then this is just a filtering for pushing metrics from the dummy buckets to CloudWatch. And of course, we have the resource creation part. So we first create the bucket. So we generate a random bucket for this experiment, and then publish metrics. And of course, we have the SQS queue creation and subscription. So we'll create a new queue and subscribe to that topic. And as a result, we have the new queue URL and the dummy bucket name. Go to the experiment.yaml. Now I want to do it together so you see how it's done. So at the moment, we have the experiment that will test. So this is just a custom action that will receive the notification. This is our steady state hypothesis. And of course, we have the method that will be to create some dummy objects and then attack the bucket. Of course, this is the live bucket. We don't want to use this one. What we want to use, sorry, let me split with this actually, is use Chaos Toolkit Terraform. So controls and name is going to be configure alarm with Terraform. And then we have the provider, it's Python module, Chaos Terraform dot control. And then arguments. The module is already in the current directory, so we don't need to do anything. We do silent false because I want to see the output. Retain true. This is just because there's if I create the resources from scratch, it will take a long time, and we don't have it in the presentation. So I already pre-created the resources. Just apologies for that. It's not the full example, but in the interest of time, I've done that. And then we have some variables to configure, especially the topic ARN. We need to connect it to the infosec topic ARN. And there we go. Now, after we have done this, the information will be exported with these two output variables. So the queue URL and the bucket name. So the queue URL, in this case, we delete the current one and add the tf out queue URL. And this will read it from the Terraform module. And then down in the method, the bucket name, we can replace change word with tf out bucket name, and again same for the lower one. Okay, so now that we have configured Chaos Toolkit Terraform for the experiment, we can run it. So library security, okay. So we do a chaos run. Hypothesis strategy is after method only, and then experiment.yaml. Hope I've done everything correctly. Let's see. And there's a problem. Why is there a problem? Never mind. String, there's an option. Yeah. So variable, no, it's R, no, variables is correct. Silent name. I may have made a mistake with the with this and bucket name. Never mind. I don't want to waste any time. I already have a working version, so I'm going to run that instead. Clear. Experiment complete. This is going to be exactly the same, except I may have made a stupid typo that's preventing me to run it. Okay. So this is what's going to happen. The Terraform will look if there's any resource to create. In this case, there's none. Otherwise, it would take too much. We have Chaos Toolkit generating the dummy objects in the bucket. And let's take a look in S3. So what will happen? We have the live access logs bucket, but Chaos Toolkit Terraform will have automatically created this dummy. And we look inside this, and we have all these dummy objects inside. Now the experiment will run the ransomware attack. We'll try to list and download all the objects in the bucket. That will give us the chance to spot an early sign of the attack. And then when the attack will complete, we'll have a ransom note uploaded into the bucket. And at that point, the SRE should have received a notification. Sorry for going back and forth. In the meantime, I'm having a look at your questions.
Great, Manuel, thank you so much for those demos. There are some questions in there that you can take a look at. And what we are also going to do is hand over to Sylvain, and then we'll do a final round of questions once you're complete.
Yeah, okay. In the meantime, the experiment completed. Now the ransom note has been uploaded, and we can see, okay, the wait for notification went through. So the experiment did receive through SNS the notification and successfully notified the security team about the threat. I hope that was interesting for all of you. That was the last experiment I demoed. I have added some additional resources here. Of course, the experiment you saw today are part of the Chaos Toolkit starter pack for AWS open source repository. So you can have a look at that and try them out for yourself. You have my GitHub page, my own blog, and as well the Chaos Toolkit Terraform homepage if you want to have a look at the documentation. Now we move on to the questions. I'll start from the top. Do we have time, Adele, or Sylvain, you want to go first?
We're going to kickstart with Sylvain, and then we're gonna do a wrap up of questions after. Thanks, Manuel.
Yeah, no problem.
Thank you, Manuel. And if I can, Manuel, please put the links into the chat, because so that everyone can obviously grab them and go and visit the awesome work you've been doing with all of that, because there's so much more to explore than what you've shown today. So thank you very much, and we'll probably have a few minutes left for the questions. I'll try to make it short. So Manuel has shown us something very interesting here, is that Chaos Toolkit adapts itself to many scenarios that you have. And it's interesting to me because it's where we started. We never thought of Chaos Toolkit as a fault injection tool. It's more of a glue, and you build a scenario of what's something that you want to try, and you build with, like Manuel said, with all the tools that you have at your disposal. And there is so much on cloud providers with so many APIs that a lot of us don't just use, like deleting things and removing a connection between things. It's all available there. But what Chaos Toolkit tries to do is to bring a storytelling to doing that altogether. And I think Manuel's demos have shown that very, very well, is you're building a case to create evidence, create facts of if this happens, this is what we see happening. And with all those facts and all those evidence, you build something very interesting. All right, so I'll do a very quick demo if demo gods are with me, because they tend not to be. So you have to be resilient when you do demos. You really do. All right. I'm guessing it's a one. Are you seeing, I guess what I'm seeing, which is a Reliably dashboard here?
Yes,
anyone? Yeah, sure, great. All right, so at the start of the week, I'll tell a little story very quickly. At the beginning of the week, I cooked pastas for my daughter, because apparently at 4, you only eat pastas. And I burnt my lip. And I thought, okay, that's not a problem. That's, not ideal, but it's not the end of the world. Next morning, I woke up, no links between what I'm going to say, and I couldn't actually move. My lower back was completely locked, and I spent a very, very bad week, basically. Now, I'm not saying that to get any ergs or anything, but it really proves the point here that we've got the capacity for resilience in the organization at the very, at the very individual levels. But look, let's try to unfold this. I couldn't actually spend time with the team as much as I wanted this week. Actually, I had to, cancel a lot of things. What does this mean? That my team had to deal with this out of the last minute, obviously. Now, most healthy teams, I guess, and where you have a good vibe between people, will simply cover for each other in that case. But that's not sustainable. You can't do that for too long. And that's not driven. That's not engineered, if you will. That's because people do that, right? They help each other. Now, if we unfold a little bit more, we get to the organization level. They think our team is, 100%, and they've based a lot of scenarios over that, and then it doesn't happen, right? So what we see is why resiliency is key. It's just it's at the will of something as stupid as one individual not being able to, stand up in the morning. So what do we do with that? We can engineer practicing not resiliency per se, but how we deal with those issues, the question of what do we do if this happen, of X, Y happen, because those are internal signals. But then you have external signals where, I don't know if you've looked at the world in the last few years, but it doesn't look very good, right? It's not, geopolitical things. COVID happened. It restructured the entire, workforce. You have supply chain issues if you're in that world, and all of that forces organization to continuously think, okay, how do I deal with this, right? How do I navigate all of that? And this is where resiliency is a key core attribute. It's not something you sprinkle or you hope for, or you let people sort of deal with it at the individual level. You need to engineer it. You need to fix a cap, a goal to say, okay, how do we get better at this? Because the world is not stopping being what it is. And we have to figure it out, how we learn to deal with those things together, right? It doesn't mean you can cover all the scenarios in the world, like Manuel showed. That ransom attacks is one of them. It's not all of them, but at least you sort of get a feeling of how the team reacts, where you need to put effort and support and help the teams to do their job, because most of the time people just want to do their job in good conditions. That's all they ask for. So this is the core of what Reliably is all about. Is we think that you can engineer bits and pieces of your resiliency. Reliably is not telling you you're resilient. That's you. That's you. You know yourself much better than anyone else in your organization. But it tries to bring to you how you can engineer that, how you can work at it. It's fully based on the premises of chaos engineering, of the idea of let's try a scenario and see what happens. So Reliably is fully settled on using Chaos Toolkit. Actually, the entire thing is based on Chaos Toolkit. So everything you've seen Manuel doing would work on Reliably, because we don't do anything stupid or that. So you can start small, and you can start small. You can start with, like Manuel said, you can start small and with open source tools. And if you need at some point to have more of a central organizational view of things, you can move on to Reliably, and we would be happy to welcome you, obviously. But there is no shenanigans here. We're still very much open source driven. So we support the Chaos Toolkit. That's, you know, a main, you know, open source project. And we love when someone like Manuel shows us what they've done with it, because to us, it's really exciting. All right, now I'll go very, very fast because I don't have a lot of time. So how does this look like on Reliably? So Reliably, we try to simplify, make it a little less code-centric and perhaps less, a bit more visual to build experiments. So I'm going to build an experiment that that simply injects some faults into a Google Cloud load balancer. So I'm using our builder to do that. The builder is simply saying, okay, I'm going to inject some faults into, you don't have to, if you're not familiar with GCP, it's fine. You don't have to worry about the details. I'm just saying for pass there, you're going to inject, you're going to respond with I'm a teapot answer for 50% of the request if you can. Now, you're going to do that. I'm going to add a pause. I'm going to do this. So you're going to do that for 127. It's long because the load balancer of GCP takes time to reflect the change you've asked for it. And as a rollback, so just like, might as well copy. As Manuel showed, you want to leave the system clean, obviously. So you do that. Now, what if we want to add, you know, a bit of traffic? Well, we can. We're going to pick up the right thing. Hold on, because obviously Slack is always in your view. This is a stupid service that simply returns a JSON endpoint. So we're going to do that, and we'll run that load test for 120 seconds. Now, we're not a load testing tool. You can integrate with Gatling, with, you know, anything that you want, K6. It doesn't matter. Again, it's Chaos Toolkit behind the scenes, so you use what you work with. And we may try to have verification, the steady state. We'll see if we get to that point, and we'll say, okay, we'll say for that pass, we should have no failures. We know we're going to get some, but, you know, it's fun to see if that's the case or not. We're going to run the load test in background, because otherwise it's going to run first the load test, and we're not going to learn anything. And we'll simply run that. So here I've created an experiment that injects an error into a load balancer, wait for a little bit, run a load test behind the scene, and verify that we didn't get an error. Obviously, we'll get. You could decide you have a tolerance for a certain given number of errors. At stage, we save the experiment, and this is an experiment, exactly what it's going to be, exactly what you've seen with Manuel here. So it's just an experiment. We're going to run that, and we'll run that from Reliably's cloud, but as you can see, you could run that from Kubernetes as well. So in that case, you would use the Kubernetes cluster you've given us access to, and we just jump onto that and run that from there. We could run from GitHub as well. We run where we push a change, and it creates a workflow and runs from GitHub so that you have more control. We're going to give an environment, so we've got, you know, access to the GCP endpoints, and we're going to run that. I'm going to select a bunch of integration, and we'll come back to that later. It doesn't matter. And we're creating the plan. Now, the plan is going to run. So while it does that, because we are very short on time, I've run that a bit like Manuel has done, and I'll show you an example of what happens in the, you know, previously. So this is exactly the same experiment as I've just run, but, you know, I've done that a little bit before. And basically what you see is the journal results, the results of the run. So what we see is we injected, okay, this is the steady state, so leave that for now. We've decided to inject our 418 AMA teapot to 50% of our requests, and we run some load tests, and this is what we got. Now, it doesn't get 50% overall because, like I said, it takes time for GCP to reflect across globally on their load balancer. It's a global load balancer, so it takes time to get there. So only after a while do we get almost 2 minutes in the case of GCP, at least 90 seconds, did we see the effect of fault. It's GCP latency for applying the fault. And we simply get to see that, and obviously you can investigate and see what happens. But what's interesting is at the end, we asked for the steady state to say, we don't want, like I said, I don't want any failures, and this is what we get. So here with Reliably, what we saw is a very quick way of creating an experiment, running it, and getting information. And the last bit before I get back to Adele, because she's showing me, she's the eyes now. When you go back here, you've got some scores that you're building after time. And what you have, and notably this one is scoring, where you have the freshness, first the score, it's how much you deviated. So sometimes you created something where you prove that you're not in fault, and sometimes you had other failures in your graduation. And then you want to see how far back is this, right? So this is very fresh. I know what I'm talking about. This is very old. Even though it didn't fail, it's almost a month old. So to me, that information is not as useful as it used to be. And I don't want to take more time because I know we don't have. So I'll pass on now to Adele for finishing the talk today.
Great. Sylvain, thank you so much for that demo. We're going to head over for some questions. Manuel, did you want to pick up on some of the questions that were asked?
Yeah, I think there was one question from Alex about that Sylvain already responded. It's about balancing the weighting when we have the creation resources before an experiment. So balancing the weighting and the speed. So he's probably asking if it's best to use persistent resources because they're quicker and we don't have to do some random weighting. Well, actually, that's true. If you need very high throughput, it really depends on your use case. But yeah, if you need a fast execution, you don't want to wait for resources to be created, and that's one use case. Otherwise, in my example, I didn't use random weights, but rather polling. So every few seconds, it would verify for the service deployment to be completed. So we actually only wait for the necessary amount of time. We don't waste any long amount of time in waiting for the resources after the creation. So yeah, the answer is it depends on your use case. Yes, it is quicker to pre-create resources, but most of the time it's fine. You can wait a couple of minutes for the experiment to orchestrate.
Great, thanks, Manuel. Does anyone else have any questions? Feel free to unmute and say hello.
By the way, if you have questions afterward and you're in the Chaos Toolkit Slack community, I'm also there, so you can feel free to pop any question there. I'll come back to it and answer it later.
Great, thank you so much, Manuel. Well, I think what we'll do is we'll wrap up today's session. Obviously, everything that you've heard today, we will be sharing some useful resources after, and obviously you can reach out to myself or any of the speakers directly, and hopefully you can also join us if you're not already in the Chaos Toolkit Slack channel. Please do have a search and come over and join us. We hope you enjoyed the session and hope everyone has a great day. Thanks, everyone.
Thank you, Adele. Thank you, Manuel.
Yeah, thank you for listening. It was a pleasure.